This is section 10.3, solve quadratic equations by graphing. Okay, so far the only way we know to solve quadratics is by factoring. So we would be given something like x squared minus 6x plus 5 equals 0, and we would factor it into x minus 1, x minus 5, and then we would set each side equal to 0 and solve, and we would get x equals 1 and x equals 5. So now another way of solving is to graph and look for where the equation or where the function crosses the x-axis. So if we graphed x squared minus 6x plus 5, we're just looking for the x-intercepts. And when you graph it, you can see that it crosses the x-axis at positive 1 and positive 5. So it's just a different way of solving. So when we graph a quadratic function, it can have either two solutions, one solution, or no solution. So a quadratic equation with two solutions just means that it has two x-intercepts. So it's going to cross the x-axis in two places. So that's what's going to occur most often. So it could look like this example, or remember, if it's negative, it's going to face the other way. But that's okay, it could still cross in two places. Okay, if it has one solution, that means it has one x-intercept, so it's just going to cross the x-axis once. So if that happens, that's going to be the same thing as the vertex and the axis of symmetry. And again, that could also happen in the other direction. And then it has no real solutions if it doesn't cross the x-axis at all. So if you graph a quadratic function, so it could look like that, or it could be, down here. If it does not cross the x-axis, we say it has no real solution. So there's also multiple names for solutions. So obviously the most common one is to say solutions of a quadratic equation. So for example, the solutions of the equation negative x squared plus 8x minus 12 equals 0 are positive 2 and positive 6. Or, what probably makes sense is we can talk about the x-intercepts of a graph of a quadratic equation. So the x-intercepts of the graph occur where y equals 0. Remember back with linear equations, when we found x-intercepts, we made y 0. So again, the x-intercepts are where this function, this equation, hits the x-axis. So far we have two names, solutions, x-intercepts. We also call them zeros. So zeros of a function, same thing. Where is the function, f of x or y, equal to 0? And then the last name you might hear is roots. So if we ask you to find the roots of a quadratic equation, we're asking for the zeros, the solutions, the x-intercepts. Where does it cross the x-axis? Where is it equal to 0? Okay, so for example, the roots of a quadratic equation can be found using the graph below. What are the roots of this equation? So when it's graphed on the coordinate grid, we're just looking for where does it cross the x-axis. So on the left, it's crossing at negative 1, and over here is crossing at 1, 2, 3, 4. So the roots are at negative 1 and positive 4. And this is already graphed for you. If you're given an equation, you can graph by hand and see where it crosses. Then you have to be very careful to make sure you're accurate. But we can also graph in the graphing calculator. And for one more example, the equation y equals negative x squared minus 2x plus 8 is graphed on the set of axes below. Based on this graph, what are the roots of the equation? So remember, roots just means zeros, x-intercepts, solutions. It all means the same thing. So here it's crossing at negative 1, 2, 3, 4. So negative 4 and positive 2. So 2 and negative 4. And that's it for this section.